Bismillahirrahmanirrahim. In this session, we will discuss exercise 9.4 from the topic of additional mathematics under the subject of additional mathematics course for IGCSE and O level students. Here we have functions is defined for the interval from 0 to 2 pi, and each function write down the period and equation of asymptotes. So we have fx is equal to tangent 4x and fx is equal to 2 tangent 3x is equal to fx is equal to 5 tangent 2x minus 3. So we have to draw this equation function, and we have to write down the period and equation of asymptotes. So let's solve this. This is from 0 to 2 pi. So this is 4x. So we will divide this at this becomes pi by 4 becomes the period, because this is half and this becomes pi by 4. So at pi by 8, this is asymptote. At x is equal to pi by 8, this will reach toward this pi by 8 at infinity, at positive infinity. At minus pi by 8, it will asymptotic with this one. So at this value, this becomes this, and at this point, this is 3 pi by 8, and similarly for 5 pi by 8, 7 pi by 8. Similarly, this is all. And at this point, we have this pi by 4, pi by 2, 3 pi by 4, and this is pi, and similarly so on. So this is a plot, and for this fx 2 tangent 3x, here we have this period is pi by 3, because this is 4x, this is 3x, so this is pi by 3, and we see that this is pi by 3. At pi by 3, this is 180 degree. At 180 degree, if we write pi by 3, then this 3 cancel with this 3, become pi. So at pi, this period completes. And for the other one, this is this. So this is simple. Similarly for this one, and it will shift because of this minus value. So it will shift. So this is simple plotting, simple tangent x, and this is tangent 4x. So we can see this is tangent 4x has a period at this value. At this value, the period is complete. From here to here, one positive value and one negative one. So at this point, the one period is completed, which is less than this one. So this is pi by 4. This is pi by 4. And here we have 2 pi. From here to here, we can see this and we can understand. Similarly for this tangent x, and this is 2 tangent 3x. So we just plotted it. So this is pi by 3. This is pi by 3. From here to here, this is pi by 3. And we see this. For 5 tangent 2x minus 3, this is this. This is at this value, this is. Since this is minus 3, so this is here at minus 2. So here we have this. This is one period which is measured here, and this is all for question number 7. Now go to the question number 8. Here we have y is equal to a sine bx plus c as shown above. So we have this point P. The graph passes through the point P, pi by 4 and 4. So this point is pi by 4 and 4. This is, here we have a magnitude is 4, and this is pi by 4. Find the value of a. So we have to find this value a, the value of b, and the value of c. Okay, so let's solve this question part. So in place of this, we place this pi by 4 here, and y is 4. Since c is 3, because this is initial value, intercept value, so c is 3. So this c is 3, so c is 3 here. So then this becomes 4, a tangent pi by 4 plus 3, that pi by 4 tangent pi by 4 is 1, so this is 1, and 4 minus 3 is 1, and from this is 1, so a is equal to 1. So this way a is obtained, a is 1, c is 3, b 1, b is equal to 1. So simply it can be read from the graph. This c is 3, and pi by 4 is 4. This is pi by 4 is 4. So in place of, if you place pi by 4 here, so this value becomes 4. And since we have one pi is a period, so this is simply 1. This graph shows at pi, this is 90 degree, it goes to the infinity, and so this is tangent x, simple tangent x, so b is 1. Similarly for 9, question number 9. Can easily be solved, and let's solve question number 11. Fx is equal to a plus b sine x for 0 to 360. The amplitude of f, this amplitude is 3, and the period is 90 degree. The period is 90 degree means sine period is basically 360 degree. So this c is 4. If the period is 90 degree, so this c becomes 4. And f is value is 3, and the period is this, and the minimum value of this function is -2. If my minimum value is -2, so write down the value of a, b and c and sketch the graph. So let's go to the question 11. Here we have this amplitude f is 3, period 90 degree, so this is 3, cx is equal to 360 degree, so this is 90 degree, and c is equal to 4, simple, and f minimum is -2. So f amplitude is f max and f minimum value, and the maximum value and minimum value we have seen there. So f minimum is -2, so f maximum can be obtained by this relation. So amplitude was 3, so f max is 4. So b, this is value is 4, and this is -2, so this is 1. So this value is obtained 1. So a is 1, b is 3, and c was easily obtained from the period. So this is simple. And this is plotted like this. Simple sine x, and this is 1 plus 3 sine 4x. Maximum value is 4, minimum value is -2, intercept is 1, which is 1. So this is simple. A, B, C values have been obtained and plotted. Similarly for this one, y is equal to sine x and y is equal to 1 plus sine 2x. So we have to plot it on the same graph, 0 to 360 degree. Simple sine x is this one, while 1 plus sine 2x is 1 is intercept is here, and we have plotted two graphs, two periods here, two signals. So this is the period is half of this period. So this is simple, and we see that their number of roots are 2 at this one, at this point. This one is the root and this one is the radius. This graph is intersecting at these two locations. So let's see this in the graph. This is sine x, 1 plus sine 2x. This is 1 plus sine 2x plot, red one, and this blue one is the sine x, and here it is intersecting at this point and this. So there are only two roots as solved here. For this one, y is equal to sine x, 1 plus cos 2x. For 360 degree, here we have these two terms. So question number 13 is plotted here. Here we have this intersection at this. 1 plus cos 2x is this one. And simple sine x is this. So intersecting at these 2 points. Similarly, the other question can also be solved. And here we have seen this. In the next session, we will discuss exercise 9.5. Very important one.